is a tangent line. A tangent line has to meet the following criteria. Basically, it is a line that brushes up against the side of a function, and what that basically ends up meaning is that it needs to share a point that the function shares. So both f of x and the tangent line have the exact same point, in this case 1, 1. And the last criteria there is that the gradient of the tangent line has to have the same gradient of the function. That's what makes it brush up against the side. The gradient of f of x and the gradient of the tangent are identical at that point in which they intersect. So with those criteria, you are fundamentally finding a linear equation, and so the gradient point formula, or otherwise, y equals mx plus c, these are going to be your friend in solving these particular questions. What's usually the issue is getting the gradient of the tangent line, and there are three main ways that you can typically go about it. The main way by far is going to be finding the derivative. Derivative is all about finding gradients, so if you find the derivative of your original function and you shove in the x coordinate at which you want to evaluate the gradient, you will get the gradient. Example 1, finding the tangent line. This is a very standard question. You have your function, find the tangent at x equals something. In this case, it's x equals 2. So what you want is the point and the gradient at that point. We already have the x coordinate, so a nice little starting point is to just get the y coordinate off rip, right? X equals 2, to get the y coordinate, shove that back into your original function. We now have the point. All we need to do now is find the gradient. There is very minimal information here, but whenever you have an f of x, you can always find your f dash, your derivative. And so that's what we're going to do here. To get our gradient, we're going to find the derivative of the quadratic. That's going to get us f dash x equals 2x. From there, any x that we shove into this spot is going to give us the corresponding gradient. So if we want to find the gradient at x equals 2 of f of x, we shove x equals 2 into the derivative of f of x. When you do that, you get gradient of 4. We have the gradient, we have the point, you can now shove that in your gradient point formula. Or if you want, you can do the whole y equals mx plus c thing.